Hi guys, welcome to Annie's Math and Science. In this case, in this video, we are going to see some trigonometric calculations. Okay, so for a right triangle, if it is a right triangle, if you are sure that it is a right triangle, then you can use Pythagorean theorem, which is equal to hypotenuse. Hypotenuse is actually the longest side of a right triangle, so which is equal to r. So r square is equal to x square plus y square. Okay, so these are the two legs of the right triangle and this is the hypotenuse. So always the hypotenuse square is equal to the sum of the square of the other two sides, or otherwise you can call them as legs. Okay, so this is how you can find if one side is actually missing, then you can find the third side like that. So in this case, say like you can write the sine, cosine and also tan theta using these numbers. Okay, so using these numbers means sine theta is equal to opposite over hypotenuse, cos theta is equal to adjacent over hypotenuse. Adjacent side means, see, like look at this is theta, and so for this theta, this is the opposite side and this is the adjacent side, and always the longest side is the hypotenuse. So cos theta is equal to adjacent over hypotenuse and tan theta is equal to opposite over adjacent. So in short form, to keep it in mind, you can say so, which is sine is opposite over hypotenuse, and ka, so cos is adjacent over hypotenuse, and tan is actually ta. Okay, TOA. So you can keep this in mind to remember these functions, these formulas. Okay, and also say cosecant theta is equal to 1 over sine theta, secant theta is equal to 1 over cos theta, and cot theta is equal to 1 over tan theta. So in this case, like you are going to write the all 6 trigonometric functions. 6 trigonometric functions are like sine theta, cosine theta, tan theta, cosecant theta, the secant theta and cot theta. Okay, so first of all, you can find sine theta. Sine theta equals opposite over hypotenuse. Opposite side is actually 15 and hypotenuse is 39. So 15 over 39. And cos theta is actually adjacent side over hypotenuse. So adjacent side is actually 36. Adjacent is just beside, like beside the angle. So that is adjacent. Okay, so 36 over 39. And tan theta equals opposite over adjacent, so 15 over 36. If you want to find all 6 trigonometric functions, then you have to add the cosecant theta also. Cosecant theta is equal to 1 over sine theta, so you just have to flip this fraction. Okay, so which is equal to 39 over 15, and secant theta is, you just have to find the reciprocal or just flip the numbers. So 39 over 36, and cot theta equals 36 over 15. Here also you just have to flip the numbers. This is how you can, if the numbers are given, then you can directly take the write the functions using the formula sine theta is equal to opposite over hypotenuse, cos theta is equal to adjacent over hypotenuse, tan theta is equal to opposite over adjacent. So this is how you can write the 6 trigonometric functions. In this case, like 2 numbers are given and you have to find all 6 trigonometric functions means, how can you do? The last case, like all 3 numbers were given and in here the hypotenuse is missing. So the formula for finding the hypotenuse is you have to use the Pythagorean theorem. This is actually Pythagorean theorem, which is hypotenuse square is equal to the sum of square of the other 2 sides. Okay, so in this case you have to find r square. R square is equal to 5 square plus 3 square, which is equal to 25 plus 9 equals 34. Okay, r square is equal to 34, so r is equal to radical of 34. So 34 is not a perfect square, so you have to write as it is. Now let's write the trigonometric functions. So this one you can replace here, this value is actually radical 34. Okay, so sine theta is equal to opposite over hypotenuse. So opposite is actually, this is angle. Opposite is actually 5 and over radical 34. 5 over radical 34. So you cannot write the radical functions, radical in the denominator position. So you have to rationalize it. So while for rationalizing, you have to multiply radical 34 with the numerator and also denominator. Okay. So now this is 5 radical 34 over 34. This is the answer for sine theta. And then for cos theta also you have to do the same thing because the hypotenuse is actually radical 34. So this is adjacent over hypotenuse. Adjacent is actually 3. So 3 over radical 34. Here also you can write it as same as this one. So 3 radical 34 over 34 will be the answer for cos theta. And for tan is equal to opposite over adjacent, so 5 over 3. Okay, so this is for sine, cos and tan. Now we can do it for cosine, cosecant theta, secant theta and also cot theta. For that you just have to flip the numbers. So cosecant theta is equal to 5 over radical 34 is sine theta. So 1 over sine theta, you just have to flip this. So you don't have to rationalize this number. You just have to write radical 34 over 5. And for secant theta, which is equal to 1 over cos, so you have to flip this number. So which will be equal to radical 34 over 3. And then cot theta is equal to, you just have to flip this one. So 3 over 5. So this is how you can write the trigonometric functions if one side is actually missing.